Hello friends, today we are going to have cantilever sheet pile uh, and from the simplified approach how to find out the depth of embedment. So you have seen a cantilever sheet pile and you have a dredge line and this is the backfill. There is the cohesionless bed below the dredge line, and there is the cantilever sheet pile. Now, you have seen by rigorous technique that the pressure distribution is going to be uh, quite rigorous, and there is a need for simplified approach. So in simplified approach, if you see the deflection pattern of a cantilever sheet pile, you know that the cantilever sheet pile is going to deflect like this. About this point, it is going to deflect. So this is the deflected shape of the cantilever sheet pile. And therefore, below the dredge line, above the dredge line, it is all active, but below the dredge line, this side it is passive. And on the right hand side of the dredge line, it is going to be active. And this side it is going to be below O, it is going to be passive, and this side it is going to be active. And the topmost point, if you take it as A, bottommost point, if you take it B, and if you take the dredge line as D, then ADB is a cantilever sheet pile having granular backfill, and it is penetrating a granular bed. So the properties are known to you. The unit weight is going to be gamma, and the angle of internal friction is going to be phi, and C is the cohesion. Here also the backfill soil has got unit weight, let's say it is gamma, and phi is the angle of internal friction. So in the simplified approach, what we do it that in the rigorous approach, the pressure distribution is going to be active from here up to here, and then from active, it is going to the passive side, and then it becomes like this. So this is the pressure distribution, and then when you try to find out the value of D by taking the algebraic sum of moment about the bottommost point B and equating it to 0, this gives you the value of depth of embedment. It's quite a rigorous practice. So how to make it more simpler in nature? So to make it more simpler in nature, what you can do it that the on the right hand side of the sheet pile, this is the dredge line, this is the dredge line, this is the topmost point, this is the bottommost point B. So this cantilever sheet pile, there's gamma and phi, granular backfill here, gamma and phi. This could be gamma 1, gamma 2. This could be phi 1, phi 2. But here we have taken it gamma and phi. Both are granular in nature. So in this sheet pile, what we do it that on the right hand side, the the pressure is going to be active. And you know that this is the depth of embedment, D, and this is the height of the cantilever sheet pile, capital H. So up to the dredge line, the height can be taken as H, that is the height of the cantilever sheet pile. And here, the pressure on the other hand side is taken as passive. So here it is going to be active, and this side, the resistance offered by the soil mass below the dredge line, we can take it RP. And from the dredge line up to the bottommost point, the depth of embedment, you know, is going to be D. So a simplified approach, this is active. So total height is going to be H plus D. Naturally, this pressure here, which is PA, the pressure, small PA, active earth pressure, will be how much? Gamma Ka times gamma into H plus D. That's the pressure. And the passive earth pressure is going to be also simple, Kp times gamma into T. This is called simplified approach. So, from the simplified approach, very quickly you can find out the depth of embedment. So, approximate value of depth of embedment can be found it out. And this capital PA, that is the thrust, active thrust on the sheet pile, will be how much? It will be half K gamma H plus D whole square. That is the value of active thrust. And the value of this passive RP will be very simple, half Kp gamma D square. So both PA and RP are known to you. And because it is going to deflect below this, so here, due to this passive force, we can here have a force, the resistance force at the bottom. And that resistance force is R. So whatever pressure is here, let's say this passive pressure is Pp prime. So this Pp prime equal to R. Because about 0.0, it is going to deflect, creating a passive force, and that passive force is converted into a resistance R, which is acting at B, bottommost point. So this is called the simplified approach. Now, how will you find out the depth of embedment? So we can take the algebraic sum of moment about this bottommost point B and equate it to 0. So if you do it, then it becomes quite simple. You already know that about B, it is going to be due to PA. So PA into this will be acting from the bottommost point B at a distance of H plus D by 3. Triangular variation. So you can write it. This is, let's say, equal to YA bar. So PA into YA bar must be equal to RP, that is this force, into about the bottommost point, the line of action of RP is at a distance d by 3 from the base. So into d by 3. So, or we can say half k gamma h plus d whole square into h plus d by 3 must be equal to this RP is half kp gamma d square into d by 3. So this 3, 3, 2 and 2 goes out. So you can simplify it and get a one equation. Here k is known to us because phi we know and gamma is already known to us. Height of the sheet pile is known to us. Only unknown is d. So or we can write it that k gamma h plus d whole cube minus, we can bring it to this side, kp gamma d cube equal to 0. So this is the simplified equation. We are getting it. Now you can solve this equation number 1 and you can get the value of d. So therefore, solving solving one, we get d. So d in meter, we can calculate it and then increase d by 20% to 30%. So d required is going to be 1.2 times d calculated. So in simplified approach, very quickly we know the approximate value of d. So friends, any kind of situation you can calculate by taking moment about the b and you can calculate the value of d by solving the equation. So this is such a simplified approach. There could be water table on both the sides of the sheet pile, so that you will have to take into consideration. Let's say this is the sheet pile, this is the dredge line, this is the backfill, and the water table is something like this. the water table on both the sides. So here it will be gamma T total unit weight and phi, and below this it will be gamma prime, that is the submerged unit weight, and phi. This side it is going to be gamma, and it is under water, so it will be gamma prime and phi. So like this, depending upon what is the situation at the site, you can draw the pressure distribution diagram. But this side, it is, we assume on the right hand side. So right side, it will be active, active, and left to this side below the dredge line, it is going to be passive. So the pressure distribution, easily you can draw it, taking the moment about the bottommost point and equating it to 0. The algebraic sum of the moment about B from the equilibrium conditions will give you the value of D. So friends, I hope this point is crystal clear to all of you, and shortly we will come up with few numericals, and that numerical problem you can solve it for better understanding. So for today, only this much. Thank you. Thanks a lot.